All right, so this is team two, and we're here to present to you our final team project.
Our project problem is that a chemistry professor must submit a report to his head of department, and the report must contain the first name, last name, grade, and GPA of their students in descending order. The report must also show the average grade, the lowest grade, and the highest grade in the course. The instructor also has to bring a group of students to a chemistry trivia competition, and the competition has a unique requirement that the group of students brought must not have a combined GPA of a 12.0.
In our solutions, you'll see us using the sorting algorithm to produce the report of the students' grades along with showing the lowest grade and highest grade. We also use a function to produce the average grade of the students in the class. We also use another algorithm to produce most valuable group of students who will participate in the trivia competition with the chemistry instructor.
Okay, so the algorithms that we used divide and conquer through the quicksort algorithm, which helps us to sort the grades as long as finding the highest and lowest grade in the class. We also used the brute force using the knapsack algorithm to help us to find the best group and most valuable group of students to go with them to this competition. And we also used an additional brute force algorithm to help us to find which subset provided us with that most valuable group of students, which included their names and GPA and grades. And here we will go ahead and play our demonstration right here. Hi, so right now, as we can see here, we created an input.txt file that stores the information of each student. So you see that we have the first name of each student, we have the last name of each student, and we have their grade in the course along with their GPA. And so basically it's stored in this input file for the professor. And basically when we run this program, we're going to see that when we go to our output file, we see that the output file prints out each student's first name and last name and their grade and GPA. However, the grade is printed out in descending order. So each student is printed out based on their grade in descending order. So as we can see here, we see that based on this information, we are able to find their lowest grade, which was a 60 as seen here. And we're able to find their highest grade, which was a 96 right here. And then also we're able to calculate the average grade by adding up all the grades and dividing it by the total number of students right here. And so this is what we get with our output file. Now we know another thing that with this instructor, what they wanted was also finding a group of students to take with them based on the requirement that the competition had, which was that you couldn't have a group of students who added up to having a GPA over a 12.0. That was a unique requirement for this case. And so right here, we see that it prints out using the knapsack algorithm the value of the most feasible or most valuable subset, and that is where we get 373. And so now it prints out also, we created another function that was able to print out how which subset was the most valuable subset. Um, and so right now, as we can see, it shows the group of students that produced that most valuable subset right here. And as you can see, their GPAs add up to a 12.0 along with their grades. It adds up to 373. So this will be the best group of students for him to go to, the most valuable group of students to come with him to try out for the trivia competition and everything. And so this is the demonstration of our program right here. Okay, so my name is Alfred Holland, and I was behind the implementation and planning of our selected algorithms.
My name is DeAndre Lee, and I'm behind the planning of the best algorithms used for our problem.
And my name is Eddie Jung Enoibanga, and I'm behind the design and the design of the slides and the video presentation.
Okay, and this concludes our presentation.